We have follicle-stimulating hormone, and that's going to stimulate the development of eggs in ovaries and sperm cells in testes. I must admit, when I hear the word follicle, I think of hair, not necessarily sex organs. So I don't know how that relates, but your follicle stimulating is going to be actually with sperm and egg. And then the last one that we have in the anterior lobe is the luteinizing hormone. I think that one's kind of funny in what it is. So, luteinizing hormone is going to cause ovulation in females and sex hormone secretion in both male and females. So, yeah. So luteinizing is just going to help us um, to produce the sex hormones. So specifically, it's going to produce estrogen and progesterone within the ovaries, and then testosterone in males. Okay. Now, we did not talk about the last one that's also in there that wasn't listed on the anterior lobe but is part of it is melanocyte stimulating hormone. Now, melanocyte stimulating hormone obviously is a hormone that's going to stimulate the melanocytes to work. Now, if you remember, melanocytes are actually present within the epidermis, and their specific point is to produce melanin, which is why they're called melanocytes. So what this means is that we actually have a hormone that regulates how much it is. Clearly, I must not have a lot of that hormone because I'm pretty pasty. But there's actually a little box in your book that's kind of interesting when it's talking about. Oh, there we go. That's much better. Anyway, so it actually talks about melanocyte stimulating hormone, and that it's being released at the same time that the adrenocorticotropic hormone is being released. And again, that adrenocorticotropic one stimulates the adrenal glands. So, so the fact that the body is releasing both of those type of hormones at the same time is kind of interesting, and they say that that has implications that a little bit further. That would probably mean a lot more when you actually know what the adrenals do. But we will get there. And then we might visit this back again and be like, oh, okay, maybe this is how it works. Anyway, so those are going to be the ones that are in the anterior lobe of the pituitary gland. Again, growth hormone, thyroid stimulating hormone, adrenocorticotropic, prolactin, follicle stimulating, and luteinizing hormone. And then the melanocyte stimulating hormone. It's kind of a lot for something that's the size of a cherry. That's a lot. All right, so that's the anterior lobe. The posterior lobe, again, he doesn't actually produce any hormones, so he's not manufacturing any of it, but he just stores it and then is responsible for the secretion of it at the right times. And he actually has two types of hormone that he deals with. The first one is an antidiuretic hormone, and that pretty much is what it sounds like. He is going to help with the reabsorption of water in the body system. And the way it does that, again, the kidneys are really neat in what they do, in that, I mean, they're essentially filters for the blood, but one of the things is that there's a type of receptor. So you've got something called nephrons, okay, and they're basically a network of tubes. Some of them are actually going to be blood vessels, and then there's other ones that are going to have uric acid in them. Anyway, and so these tubes are going to kind of intertwine, and when they come together, they have spots where the tubes will actually meet up next to each other. So you're going to have a blood vessel here, and then the other kind that has the uric acid in right here. Anyway, but within the blood vessel walls, they're the types of receptors that feel pressure, and so when it feels like there's not enough pressure within the blood system, there's two things that he can do. One, he can cause the veins to actually, or the veins and arteries to constrict and get a smaller hole, because again, that's going to just create a little bit more blood pressure. Blood pressure is really important. Without it, we're not going to be able to get a proper circulation through the cardiovascular system. So blood is not going to have enough force to pump back up, which would be bad. Uh, so we want to maintain a certain level of pressure within there. So he could do that vasoconstriction, or the other thing he can do is actually stimulate the posterior pituitary gland to release the antidiuretic hormone, so that what's happening in the kidneys is that some of the blood and stuff is actually merging over into this area that has the uric acid, and it's filtered so that the stuff can actually take away what is unnecessary. And then it actually puts back into the bloodstream things like red blood cells and other really good, important things. And again, he's actually going to put back some of that fluid, because we only need to release some of it, not all. So antidiuretic is going to be able to increase our blood pressure if it gets low. I must admit, I actually have really erratic blood pressure, so this to me was pretty important. I think at one point my blood pressure got to like 70/30, which is ridiculous, and I don't even know how I was moving. But we hear a lot about having too much blood pressure, and in that case they could actually decrease the amount of antidiuretic hormone that's being produced. But not having enough can also be an issue. Anyway, so that's going to be some of the issues with the antidiuretic. Also, kind of the interesting thing about that is that alcohol neutralizes this hormone. So if you have alcohol in your bloodstream, it's going to essentially kill off this hormone, so it's not going to work properly, which means you need to pee a lot when you drink. And that's specifically why. Not necessarily that you have a lot of liquid in your body, but rather it's actually messing with your hormones, and it's not retaining the water that it needs to. So I'm just going to pee it out. So that's antidiuretic hormone. The next one is oxytocin. Okay, and again, oxytocin is the one that's responsible for uterine contraction during labor. And then it also triggers milk expression. So remember, the prolactin is going to help with producing of the milk within the mammary glands, but oxytocin is actually preparing it to get ready to express it. So prolactin produces, oxytocin gets it out of the body, so to speak. Okay, and this is a type of hormone that they actually synthesize in order to induce labor. So my sister-in-law actually just had a baby on Wednesday. I'm very excited about that. And she's a petite woman. She's only like 5'1". She's little. And this baby was not. My niece was 9 pounds and 6 ounces and 19 inches long. So she had to be induced. So she got a synthetic form of oxytocin in order to be able to start being able to have labor to give birth to this child who's pretty large. It's only 3 ounces less than my other niece that she had, and that niece almost got stuck. So it's a good thing they induced that labor so that the baby wouldn't continue to grow and get too big for him. That would be an issue. Okay. So there's a couple pathologies that are associated specifically with the pituitary gland. Again, remember the pituitary gland on the anterior lobe is producing that growth hormone. So if you're producing too much of that, that's where you're going to get gigantism. And you're also going to get a disorder called acromegaly. And that's going to be where the bones of the face, hands, and feet widen. And yeah, so that's going to happen with, is that, and then other body systems are going to be affected as well, as long as the cardiovascular and nervous system. Okay, so those are two issues that are going to come with the pituitary gland. All right, so I'm going to go ahead and stop this one. We'll move on to video 3. That's we're going to start on with the thyroid gland. Thanks.